I'm going on to a new section in the WOW videos, just so you know. All those other ones that had 3K, you know, go by the letters, go by the numbers, and you can see which ones are kind of a continuing thought. I break them down into smaller videos so it doesn't take so long. Okay, so this one's formulas and ideas to be filmed. So basically there's formulas in this video, okay? So part 284C3L, line 22f1fa19c3L, diamagnetic, paramagnetic, ferromagnetic elevator. So we're talking about the space elevator here, for the UFO or spaceship 5G Wow Seti. Okay, so that's the title of it. I would have put space elevator, but it would have taken up too much room for the title. So there's the alien radio signal there. From Snell's laws, this was a keyword, obviously. So we googled magnetic force repels alloys. So what I was looking for, something that could repel alloys from each other. And so this is because it's part of the design idea, right, for the spaceship and the elevator. So classifications of magnetic materials. This is a quote by Ron Kurtus. I guess he revised it March 2012. I found this on a blog, okay? So materials respond differentially to the force of a magnetic field. There are three main classifications of magnetic materials. A magnet will strongly attract ferromagnetic materials, weakly attract paramagnetic materials, and weakly repel diamagnetic materials. The orientation of the spin of the electrons in an atom, the orientation of the atoms in a molecular alloy, and the ability of domains of atoms or molecules to line up are the factors that determine how a material responds to a magnetic field. Ferromagnetic materials have the most magnetic uses. Diamagnetic materials are mainly used in magnetic levitation, which is what we want for our space elevator design. We want a magnetic levitation, and for the spaceship as well, so that it pushes the spaceship up without having to use fuel up into outer space. Okay, so www.school-for-champions.com. okay, that's the website I found it on. So I'm going to Google diamagnetic materials to see what I can find. And I forgot to break it down here, so just do this real quick here. It's just a little bit too big chunks. Okay, so diamagnetic materials have a weak negative susceptibility to magnetic fields. Diamagnetic materials are slightly repelled by a magnetic field, and the material does not retain the magnetic properties when the external field is removed. That's very important. In diamagnetic materials, all the electrons are paired, so there is no permanent net magnetic moment per atom. Diamagnetic properties arise from the realignment of the electron paths under the influence of an external magnetic field. Most elements in the periodic table, including copper, silver, and gold, are diamagnetic. Paramagnetic materials have a small positive susceptibility to magnetic fields. These materials are slightly attracted by a magnetic field, and the material does not retain the magnetic properties when the external field is removed. Okay. Paramagnetic properties are due to the presence of some unpaired electrons and from the realignment of the electron paths caused by the external magnetic field. Paramagnetic materials include magnesium, molybdenum, lithium, and tantalum. Now, these three here are in formulas already in the WOW videos from line 17 to 22. So there is a formula with these, so you would just go into the Idea Go Says YouTube channel, and you would just type in molybdenum. It'll bring up all the videos that have that keyword in them. If not, you'll do it on the blog, because that's where I put the notes there, the research notes, okay? Ferromagnetic materials have a large positive susceptibility to an external magnetic field. They exhibit a strong attraction to magnetic fields and are able to retain their magnetic properties after the external field has been removed. Ferromagnetic materials have some unpaired electrons, so their atoms have a net magnetic moment. They get their strong magnetic properties due to the presence of magnetic domains. In these domains, large numbers of atoms moments of 10 to 12 to 10 to 15 are aligned parallel, so that the magnetic force within the domain is strong. When a ferromagnetic material is in the unmagnetized state, the domains are nearly randomly organized and the net magnetic field for the part as whole is 0. When a magnetizing force is applied, the domains become aligned to produce a strong magnetic field within the part. Iron, nickel, and cobalt are examples of ferromagnetic materials. Again, let me stop here. I have formulas for iron, nickel, and cobalt that are mentioned in the WOW videos, lines 17 to 22. Components with these materials are commonly inspected using the magnetic particle method. So it's www.ndt-ed.org, okay? So some sort of community college put that up. So November 13th, I was working on the research. Today's November 22nd, 2012 when I'm filming it. My thoughts. We would use these super alloys and various magnetic forces to create a UFO spaceship that is magnetized to land, then demagnetize the bottom part of the ship and magnetize the top of the ship. This alien technology is found in the WOW data's formulas for super alloys, the space elevator, and the UFO Outer Shell Designs. Okay, so thanks for watching. I'm going to go into the next one. Oh, just so you know, actually I was working on this on July 30th. So that shows I'm about 6 months behind. Okay, thanks for watching. I'm going to the next one.